Hello everyone, this is N. Balaraman, Assistant Professor, Department of Computer Science and Engineering, St. Martin's Engineering College. I welcome you all today for online video lecture on computer networks. I will be discussing the topic of OSI layer, covering its layers and their functionalities. Let's get into the topic. OSI stands for Open System Interconnection, which is developed by ISO, Indian Standard Organization. Okay. In the year of 1984, it has been introduced. We are going to see in this topic, the table of contents are definition, introduction, layers of the OSI model, protocols of OSI model, and the conclusion of the particular OSI reference model. So as I told the introduction, it is an open system interconnection which is developed by Indian Standard Organization. It consisting of 7 layers. Namely physical, data link, network, transport, session, presentation and application layer in the way of bottom-up approach. If you are going to discuss about the particular layer in top-up approach, we have to mention the layers as an application, presentation, session, transport, network, data link and physical layer. So these layers we can call this application, presentation and session layer as a software layers. Okay, we can call the network layer, data link layer and physical layer as a hardware layers. So this transport layer is in a heart of the OSI layer. So it will be communicating to the both sender and receiver side at the software layer and hardware layers. So why we are telling these 7 layers as in a top-up approach and bottom-up approach? So from application layer to physical layer. So application layer means, namely we can say application, presentation, session, transport, network, data link and physical. Okay. So in application layer we can say as an user data, and presentation layer we can say formatting and translation. Session layer we can say it is in a session management. Transport layer we can say connection of segmentation and delivery. Network layer we can say routing and reusability. Data link layer we can say that is consists of frame transmission and physical transmission. So this application layer to physical layer we are sending the data. For an example, this approach will happen when data will be sent from a device. On the time this application layer to physical layer, this process will be going on. Okay, na? So if you are going to know about the physical layer to application layer, So the physical layer to application layer, namely we can say P stands for physical layer, data link layer, network layer, transport layer, session, presentation and application. So in this physical layer, we are going to do the data transmission. And here we are doing data reconstruction. Okay, so in network layer we are doing that routing and addressing. In transport layer we are doing that process of segmentation and reusability. Okay, so in session layer connection will be established, maintains and terminates. Okay, so connection will be established, maintains and terminates. Presentation layer it will do translation, encryption and compression. Translation, encryption and compression. Application will be doing the application processing. So here this approach will happens when the data received to the device. When the data received to the device. This one will happen when the data will be sent from the device. That process will be happen when the data will be receiving to the device. So now as I told you, we having 7 layers, physical layer to application layer. So the first thing, physical layer will coordinates the function and required to transfer the bit stream over the physical medium. So it has to transfer the bit stream to one end to another end. Okay, the data link layer receiving the bits from the physical layer and transferring those bits to the converting the bits to the frames. Okay, so the data link layer converting the bits to the frames. Then after the data link layer sending the same frames to the network layer. The network layer will converts that particular frames to the packets. Okay, it converting the frames to the packets. Then after it will be sending those packets to the transport layer and it will be sending the packets to that particular transport layer. The transport layer role will be it will send the particular packets to the correct source to destination. Session layer will be maintains, establish the connection and it will be sending that particular information compressed, translated and encrypted to the information. Next one, presentation layer. In presentation layer it will make the information efficient and application layer it will be used to provide that user interface and make that data to save in the application processing. Now I will show the small representation of physical layer and the data link layer. So the physical layer it's going to interconnected with a number of coaxial cable and optical fiber cable which is used here. The data which will be going as a bit transferring. Physical layer will converting the data to bit transferring and the data link layer will change the data to frames. Okay, na? By using the MAC header, IP header, TCP header and HTTP header. Okay. So now you can see that layers of physical layer. As I told, the physical layer is the OSI layer, topmost layer. It will be transferring the physical bits, raw bits to the one end to the another end. So for that, the raw bits will be transferring to the physical layer, from the physical layer to data link layer. So the individual bits will be converted to that so we can say bits synchronization. Bits synchronization and bits control physical topologies these are the methods of physical layer, functionalities of physical layer and transmission mode. Transmission mode. So here in bit synchronization, okay, in bit synchronization for sender side and receiver side, sender side and receiver side, the bits will be traveled. During the travelation of bits, there will be one clock will be provided. That clock will be managed and provides synchronize the particular bit level. It provides synchronization of bits level. Next, bit control. That bit control will manage transmission rate. That bit control will manage transmission rate. So what do you mean by transmission rate? The transmission rate is nothing but how much bit per second it will be has to be transmitted. How many bits per second it should be transmitted, that is called a transmission rate. Physical topologies, it is an element of design computer networks. It's an element of design of computer networks. So from this element of design we can derive the physical topology of, for an example, bus topology, ring topology, mesh topology or star topology. Okay, so these are the three: bit synchronization, bits control and physical topologies. Next we are going to know about the transmission. Transmission mode. In transmission mode we having three methods: simplex, half duplex and full duplex. We already know what is simplex. Simplex is nothing but it is an unidirectional connection. Half duplex is nothing but it is bidirectional. But not simultaneously. But not simultaneously. Full duplex is bidirectional connection. It will be simultaneously, it will be done. For this unidirectional, we can say the example of keyboard. For this bidirectional, not simultaneously, we can tell this example of walkie-talkie. And for the simultaneous, we can say mobile phones. Mobile phones. Okay, now. So these are the physical layer functionalities. Functionalities of physical layer. So if you are coming to the data link layer having data link layer will converting the bits into frames. After conversion of frames, it will be doing the such functionalities of data link layer. It's doing framing, physical addressing and error control. Okay. So the framing is nothing but it's providing the way of how the sender will receive the set of bits that will be meaningful to the receiver. So those bits will be converted to the frames that will be making meaningful to the receiver. Next one, physical addressing. Physical addressing that will be make that particular data link layer which adds some physical addresses. That physical address is nothing but MAC address of the presenter devices which will be available in the current network. Okay. So for an example, the physical address will be found out by the data link layer. If any error occurs, if the, for an example in data link layer, we will send the data. Okay, now data is nothing but frames. So those frames will be sent from the one source to the another destination. So during that particular transmission, we having the flag bit. Flag is nothing but it is an datagram. In the datagram, we having flag. Within the flag, we having header. After header, we having source. Then information nothing but payload. Then after destination, then trailer part. Again, we having flag. That is called a datagram of particular data link layer. So here in this data link layer, it providing converting the bits into frames. Okay. So after converting the bits into frames, it's doing that error control, flow control, access control. What do you mean by error control? It provides a mechanism of control which has to be in DDIX and which will be retransmit. So for an example, if you are doing one transmission, okay now, so from one end to another end, from sender, the sender is sending some frames to the receiver side. Okay. During the transmission, the receiver will receive the frames which is ordered by the sender, which is sent by the sender to the receiver. So on that time, the particular frames has to be traveled to the receiver side in order. Okay now. So for an example, the receiver does not able to receive the particular frames in order, or otherwise during the transmission, if any error occurs, otherwise during the traffic time the error occurs, the damaged packets will be damaged or frames will be damaged. On that time, the retransmission will be established by the receiver side to the sender. Retransmission will be established by the receiver side to the sender. So then after, the sender again has to retransmit the frames to the receiver side once again. Okay, that is called error control. Next one, flow control. So the flow control is nothing but it is in a range or rate which will be maintained by both sender and the receiver side. So the sender has to maintain the same bit rate or speed rate of the receiver side, then only they can transmit the information successfully. For an example, if the sender is sending some information in a 1 Mbps speed, okay, receiver is going to receiving that speed, that information in 512 kbps speed means there may be some lag will be occur. So the data will not be received to the receiver properly. So what happened? The receiver sender will send the data. The receiver is not able to receive the data properly. Then what will happen? The data will not be stored properly. At the same time, congestion will be occur. Okay, na? So on that time, we have to retransmit the packet to the receiver once again from the sender side. Okay, access control. So the access control, for an example, we are using the single communication channel. We are using the single communication channel which is shared by the multiple devices. So here the MAC sublayer is provided to the help to determine the how the data will be controlled in the particular session. Okay. So here in data link layer, we are doing this converting the frames. After converting the frames, we are doing the error control, flow control and access control. We are doing the framing also. Okay. So next we are coming to the network layer. So the network layer will ensures that particular packets will be delivered to the correct destination. So the particular packet, how it's going to enter to the correct destination? By the way of routing. The routing is nothing but to finding the specific path within the traffic. So how are you going to finding the specific path within the traffic? So if you want to send some information, so sending some data to the one end to the another end. Okay. So the network layer, in network layer we are sending some information from one end to the another end. So for an example, routing, we can take a simple network. Assume that this is a simple network. Here we are going to do the routing. Okay. For an example, if you are going to route some packets here, So if the A is going to send some packets, packets to the D. Okay, now so it's going to route the packet to the D. Once the A receives the packet from the D, A sends the packet to the D, D receives the packet from A. Then after the D has to route that particular packet to the entire connected nodes. The D has to route the packet to the entire connected nodes within the simple network. So that is called routing. So finding the best path, we are using the routing concept. Okay. So for an example, I will show one demonstration of video. Routing. For routing is nothing but it is in finding a specific path within the network. For an example, you can see this simple network diagram. So if A is sending some packets to C, okay, so the C has to receive the packet and has to route that particular packet to the entire network. Okay, otherwise the C is sending the packet 3, the C is sending the packet to D, the D has to route the entire packet to the particular simple network. Okay, now this is called routing. So in this we have to find the specific path of the particular transmission. Okay, so I will show one demonstration of network layer and transport layer operations. So here in network layer, it having internet group message protocol, internet control message protocol and internet protocol, which will be sending to the router, and it's providing that IP sector. Within that, it will be sending the information as a package to the correct destination. So in transport layer, we are using that particular transport layer will be provided, and it's having the protocols of TCP and UDP. So the TCP role will be, it's providing connection oriented protocol. We can call it as that particular TCP as a reliable connection. So UDP is nothing but it's a connectionless protocol. It will be sends the data, but it's not wait for acknowledgement. But the TCP will sends the data and it will wait for the acknowledgement. If any error occurs, it will be retransmit the data. So if for an example, it will sending some data from the TCP, waiting for acknowledgement. That's why we are calling as a reliable transmission. The UDP will thus not provide the acknowledgement. You can see this diagram. We are inspecting this one. We are finding that these are received packets. In between, we have one corrupted packets. Okay. So this should be discarded. Okay, na? This should be discarded during the particular transmission. Okay. So next we come into the session layer. Session layer will establish, maintains, synchronize and terminate the connection. So the session layer will provides maintenance, termination and establishment of connection. First of all, it providing the synchronization. So in its synchronization, which will be considered as a synchronization of points to the particular data, and it having the dialogue control also. The dialogue control is allowing the two systems of communication with each other within the half duplex or full duplex method. Okay. So in this session layer, after completion of session layer, we are coming to the presentation layer. We can call this presentation layer, which is doing the job of translating, encrypting and compressing the data, which will be sent out by the session layer. Okay. So here it extracting and manipulating the required format, and it will be transmitting to the new data. Okay. So this is the diagram of presentation layer. So when it is going to the different type of approaches, we told top up approach and bottom up approach. Okay. So this is the presentation layer. So next, if you are coming to the presentation layer function, we having whatever we told, translation, encryption and compression. So in encryption, what we are doing, we are encrypting the data. For an example, we are converting that to plain text to ciphertext. Okay. So the plain text is nothing but unreadable format. Ciphertext is nothing but readable format. Okay. So this is the application layer. In application layer, we having the process of application will be processing. For an example, HTTP hypertext transfer protocol, which is used to the web pages. Okay, now it is we can take a hypertext is nothing but web pages. Application layer consisting of HTTP, telnet is nothing but telecommunication, while we can access in the remote server. Okay. Next one SMTP, simple mail transfer protocol. We can transfer the mail via Gmail or otherwise Yahoo like that. Okay. So this is the application layer. In this application layer, functionalities will be network virtual terminal, file transfer access management, mail services and directory services. So these are the protocols that will be involved in the particular OSI model. So what are the protocols? Physical layer consisting of optical fiber, UTP cable, routers and hubs. So the optical fiber will carry the light pulse to transmit the data. Okay. Data link layer will providing Ethernet, which is nothing but wireless local area network. Switch is nothing but it will be finding the MAC address, it will be transmit the information to the correct route. Okay. Bridge is nothing but by the segment of network, the multiple network, it will be adding to the single function network. Network layer we can say API socket, application program interface socket, which is used to create the application program and function the application programs. Okay. So NFS network function system and system block messages, IPv4, IPv6, ICMP, Internet Control Message Protocol, Inter-IPsec protocol and IGMP. So the transport layer having TCP and UDP protocol, transmission control protocol, user datagram protocol. So ICMP is nothing but Internet Control Message Protocol. So for an example, if you are sending number of data, number of packets, okay na, at the same time, it will control the particular messages through the Internet Control Message Protocol. Internet Group Message Protocol will multiply the networks, multiply the data which will be sent to the one source to the another destination. So here we are using compression and encryption of presentation layer, SSL, TLS and SSH. Secure socket layer, transport layer service and SSH. So the secure socket layer during the transit of the data which will be transmitted to one end to another end in remote server. Okay. So for that it will be making the encryption and the secure communication will be provided in this particular SSL. The TLS is nothing but transport layer services. It is the advanced version of SSL which provide the stronger encryption and secure communication. SSH is nothing but it is the authentication of the remote server, the data which will be provided as an encrypted one. So as I told already, HTTP, hypertext transfer protocol, which is going to send the web pages, and the particular FTP will be used to the file transfer protocol. We can transfer our files, for an example uploading, downloading and managing the systems. SSH already we discussed here. DNS, domain name system. Domain name system is nothing but to finding the particular domain name. For an example, if you are searching for the e-commerce, if you are going to searching for the e-commerce, you have to type Flipkart. If you are typing Flipkart means the system will take the particular IP address of Flipkart and finding the Flipkart IP address, it will be visible the particular web page or screen in your monitor. Okay, it will be visible the particular web screen in your monitor. That is called a domain name system and telecommunication network, domain host configuration protocol and ping. Okay, now these are the protocols of OSI model. Thank you.